In this video, we are going to talk about displacement reaction. In these kind of reactions, a more reactive element displaces a less reactive one from its compound. And the general equation of these reactions looks something like this. Here A is a more reactive element and B is a less reactive element forming a compound with C, BC. Now A will displace B, it will kick out B and form a compound with C, AC. And finally we'll get B separated out. Now you might be wondering, Ram, why are we even talking about this? What's the use of this reaction? So see, in our daily lives, we depend a lot on pure elements. Like the houses that we live in, they are standing on strong pillars made of pure iron. And the electricity that we get in our houses, they are transmitted using wires, connecting wires made of copper. So these pure elements, they help us a lot in sustaining the kind of life that we have. But the question is, how do we get these pure elements? When I was a kid, I used to think that, we generally find rocks of iron somewhere under the earth, or rocks of copper, or rocks of silver somewhere under the earth. And we go and extract them and mold them into whatever shape that we want, and we kind of use them. But that's not true. Actually, these pure elements, they mostly occur in combined state, in a form of a compound. Like iron, you might find iron combined with oxygen as iron oxide. Now the question is, how do we get iron out of this? So one way could be that you burn this, you heat this with carbon. Now carbon being more reactive, this will kick out the iron from its oxide. And finally we'll get carbon monoxide. And then iron will be separated out. Plus iron. And we can use this to make whatever we want. Similarly, another example could be if you want silver, but all you have is silver nitrate. So how do you get silver out of this? Now one way could be that you react this with copper. Now copper being more reactive, it will kick out the silver from its nitrate. And finally we'll have copper nitrate and silver will be separated out. Now you can use this silver to make whatever jewelry that you want. Now these examples are of displacement reaction. You can see that in all of these examples, one highly reactive element is displacing a less reactive element from its compound. Copper is more reactive, it's displacing silver from its compound. And finally we get these pure elements and we can use them. So displacement reaction can be very helpful in many cases in fact. And now that you understand the use of this, let's go ahead and solve some examples. So here I have three reactions. And all of these three reactions are going to happen. They are going to proceed. Meaning I'm telling you that iron here is more reactive than copper. Here zinc is more reactive than copper. And here lead is more reactive than copper. Now can you pause the video and think about what are the products that are going to be formed in these reactions? Pause the video and give it a try. Now if you have tried it, let's see. So in this reaction, since iron is more reactive than copper, iron is going to displace copper from its sulfate and form iron sulfate. Iron sulfate, SO4. And plus we will get copper atom displaced, separated out. Similarly here zinc is more reactive, so it will displace copper out from its sulfate. And finally we will get zinc sulfate plus copper atom. And similarly here lead is going to displace copper and form lead chloride, PbCl2. And along with this, copper atom will be displaced, copper atom. Now after this, let's look at a slightly different problem. So here I have copper in iron sulfate solution. What do you think will be the product in this case? Pause the video and give it a try. Now if you have tried it, let's see. So see, we have earlier seen that iron is more reactive than copper. So that means in this reaction, copper is less reactive than iron. That means copper cannot displace iron. It cannot kick out iron from its sulfate. That means that this reaction cannot proceed. It will not happen. And we will have iron sulfate and copper in it. Now you might be wondering, Ram, how am I supposed to know which element is more reactive than the other? So for this, scientists have been doing a lot of experiments, lot of reactions, and they have prepared a list. They have listed down, they have organized all the elements or most of the elements in order of their reactivity. So this is the reactivity series. Well, it does not have all the elements, but the ones that we are going to use the most. Now see, in this series, the element that is higher up is going to be more reactive than the element that is lower in the series. For example, here calcium. Calcium is above, let's say, aluminium. So calcium is more reactive than aluminium and it can displace aluminium from its compound. Whereas calcium is lower than sodium in this series. That means sodium is more reactive than calcium, or calcium is less reactive. That means sodium can displace calcium. Now with the help of this series, let's try to solve a couple of more problems. So here I have two reactions. Now I want you to pause the video and see that which reaction will proceed and which won't, and also write down the products of it. Pause the video and give it a try. Now if you have tried it, let's see. So in this first reaction, we have hydrogen. So hydrogen is somewhere here in this list. And then we have magnesium chloride. So magnesium is somewhere higher up in the list. That means magnesium is more reactive than hydrogen. Hydrogen is less reactive. So that means hydrogen cannot displace magnesium. And this reaction is not going to go further. This will not go further. Whereas here if you see, iron is somewhere here. And copper chloride. So copper is somewhere here. Okay, copper is lower than iron. That means iron is more reactive. And since iron is more reactive, it can displace copper from its chloride. And finally we will get iron chloride. And copper will be displaced. Copper will be displaced. So now you might be wondering, Ram, how do I remember this long series of so many elements? So for this, I use a mnemonic. I call it the careless zebra mnemonic. It's read as, please stop calling me a careless zebra. Instead, try learning how copper saves gold. So now you can see that, the first letter of please can help you remember potassium. And the first letter of stop can help you remember sodium. And so on and so forth. So with this series in mind, you will be able to remember the reactivity series. Now once again, let's see. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. Now that's all that you need to know about displacement reaction. But if you are still wondering how are things happening at an atomic level, then let me give you some idea with the help of this animation. So I have a container and I am going to put copper sulfate solution into this. Now by copper sulfate solution, I mean I have put copper sulfate crystals in water in an aqueous medium. Now whenever copper sulfate is put in aqueous medium, it dissociates. It breaks down into copper 2+ ion and sulfate 2- ion. And why this dissociation happens is something that we'll talk about in a separate video. But many compounds do this. Like if you put HCl in water, it will dissociate into hydrogen plus ion and chlorine minus ion. If you put sodium hydroxide, NaOH in water, it will dissociate into Na plus ion and OH minus ion. So okay, now I am going to put iron rod into this, a pure iron rod. So this is going to be made of iron atoms, like this Fe atoms. Now see, iron is more reactive. Now by that I mean that iron has a higher urge to become more stable. So see, over here iron atom is stable, but it can become more stable by losing electrons, by losing 2 electrons. So over here iron is going to lose 2 electrons. And here copper ion, copper plus 2 ion, which is positively charged, is in need of electrons. So iron will lose these electrons and copper will take them. So iron atoms, they will lose electrons, and copper ions, they will accept these electrons and they will become neutral atoms. Similarly over here, iron will lose electrons and copper will take in electrons. And these copper atoms are going to stick to this iron rod. And now this iron atom that has lost 2 electrons, it is going to become positively charged. And this positively charged ion is going to be attracted by this negatively charged ion. And that's how we get iron sulfate. And as time passes by, more and more copper atoms will be deposited on this iron rod. And more iron atoms will come in the solution and they will make iron sulfate. And that is how iron replaces copper from copper sulfate solution. Now if you're wondering what happens in the opposite case, when we have copper in iron sulfate solution. So see, the moment I put iron sulfate in water, it is going to dissociate. It will break down into iron plus 2 and sulfate minus 2 ions. Now when I put copper rod into this, there will be no reaction taking place. Because see, now iron plus 2 is very stable. It is very happy. It does not want any electrons. So it is not going to go towards copper and take electrons from copper. And that's why we will always have iron sulfate in the solution and copper atoms will be stuck inside this rod. Now this atomic picture, this surely helped me solve a very old doubt. I was very curious that when iron is reacting with copper sulfate, why can't iron displace sulfate ion and form copper iron molecule, and then sulfate molecule will also be there? Why can't this happen? So now I know that, hey, iron over here, this will also be positively charged and copper will also be positively charged. And positively charged atoms, they cannot attract and form a molecule. So that's why this will be wrong. Okay, let's now summarize the video. Here we talked about displacement reaction, in which a more reactive element displaces a less reactive one from its compound. And we also saw the reactivity series, and we saw the careless zebra mnemonic to remember it.